So in this session, we're gonna complete the rest of the topics from exceptions. So in the last session, we discussed until exception with files. So next is methods, exception with methods. So we are going to talk about where exceptions should be handled and how to design your methods so errors are clear, useful, and not messy. So let's start with a simple rule. You catch exceptions only when you can do something useful. So if you can't recover, let it bubble up to someone who can. That's called propagation. So it sounds fancy, but it just means don't trap an error in a low level method if the higher layer is the one that knows how to respond. So think about layers in a typical app, where a data layer that loads files, a logic layer that processes them, and a UI layer that talks to the user. So if the data layer hits a file error, it can't loop a dialog. That's a UI decision. So the data layer should signal the problem upward. The UI layer decides whether to retry, show a message, or pick another file. So yeah, that's how it works. So we have wrapping low level errors into domain errors. So when a low level API throws something like IO exception, the data layer could pass that raw exception upward, but it's often better to wrap it in a domain specific exception that matches your app's language. For example, instead of uh, instead of leaking IO exception everywhere, throw a data load exception that the cause, the original IO exception, gets attached, so you don't lose the uh, uh, stack trace. So why is this useful? Because callers see what failed in their terms, which is loading, like for example loading students failed, while you still keep the original technical details for debugging. uh, it's clear at the boundary, detailed under the hood. So uh, there are two entry points, which is a throws method and a safe method. So really practical pattern is to offer two versions of the same app operation. We have For throws we have so the a strict method that throws if something goes wrong. Like for example, uh, you could say student dot path, actually. So this throws a data load exception. This is great for other developers or layers that want full control. They can catch it, log it once, decide, retries, or escalate. Whereas the safe method that never throws and gives a friendly no data signal, like something like this. Repo, uh, yeah, this returns optional, you know list of students. So this one catches, logs the cause once, and returns the optional empty list if it couldn't load. It's perfect for UI or simple tools that just want to ask did it work without a lot of ceremony. So the key detail is log once, don't log, and then rethrow and then log again at the top. That creates duplicate entries. Either log in the layer that consumes the error or log in the layer that converts the error, not both. So we can imagine uh, the UI calls StudentRepo uh, load path when the user chooses a file. So inside the load, we read the CSV using NIO. If something goes wrong, file missing, unreadable, bad format, we wrap it in the new data load exception, something like could not load students from your path and your cause. Yeah, and throw it, and back in the UI we catch the data load exception once. We don't print a scary stack trace to the user. We show a clean alert like could not open file at path. So something like, again, please check the location or permissions. So that's it, one clear message in the right layer. Now the alternate entry point is somewhere else in the app, maybe a background refresh. We call StudentRepo.tryLoad path. This method catches low-level exceptions, logs a single line with cause and path, and returns optional empty list. So the caller can simply check if present, great. If empty, show a small non-blocking yeah, if it's empty, show a small non-blocking notice or keep previous data. So two methods, two audiences, strict for power, colors, safe for convenience. And then we have optional versus exception. So when should you return optional and when should you throw? So use exceptions when something went wrong, a broken precondition, a failed input output, a corrupted file. That's not normal. Signal it loudly. Use optional when missing is expected and normal. For example, there may or may not be a cache file. That's not an error, that's a state. So optional is perfect for those kind of situations. What not to do is you don't return null. Null hides the intent and invites null pointer exception. If absence is normal, use optional. If it's abnormal, throw an exception. And good practices. So there are a few things that you want to avoid is leaking low-level exceptions to the UI. So if your button click handler shows java.nio.file.no such file exception, that's a leak. So user needs plain English messages, wrap low-level exceptions before they cross into UI, and double reporting. So logging in the repo, so catching in the service and logging again, then catching at the UI and logging again. So pick one spot to log. Usually log at the edge, which is the top level, or where you convert exceptions, not both. And returning nulls. Use optional for might be absent. Use exception for something like something goes wrong. So that's how you design exceptional friendly methods. Clear contracts, clean layers, and zero drama when things go wrong. So that's about exceptions with methods. Next we have, now that we have talked about how exception works, let's move into something a bit more creative, writing your own exceptions. So sometimes the built-in exceptions in Java, like IO exception or illegal argument exception, don't really describe what went wrong in your program. So that's where you use user-defined exceptions. uh, they they let you communicate errors in the language of your application. So when should you create your own exception? So only when you need to express something specific to your program domain. For example, imagine you're building a seat reservation system, maybe for a concert or movie theater or even a classroom simulation. So if someone tries to reserve a seat that's already taken, you could technically throw something generic like illegal state exception, but that's not very descriptive. So instead, you could define a custom exception called seat already reserved exception. So that name alone tells you exactly what the problem is and where it happened. So the goal is clarity and precision, not just having your own fancy class. So how do you create one? So you make a class that extends either exception or runtime exception. So the choice depends whether you want it to be checked or unchecked. So if you extend exception, caller must handle it with try, catch, or declare throws. If you extend runtime exception, handling it is optional. It'll bubble up unless caught. So for domain errors where program can recover, like seat already reserved or insufficient balance, making it a checked exception is often clearer. If it's a programming mistake like null pointer or invalid state, use unchecked. So inside your class, always provide a meaningful message, and if it helps, a context field like seat number or user ID. So this gives you a rich error information later, both for users and logs. So let's imagine example. So we have a method called reserve string seat ID inside a class like seat manager. So when you call it, it first checks if that seat is already taken. If it is, it throws a new exception like something like this. Something like this, new seat already reserved exception, your seat ID. That's not given. Yeah. Alright, so that custom exception might store the seat ID internally and build a message like seat A3 is already reserved. So now the caller, maybe your main program or GUI, can catch the specific exception and show a friendly alert, something like, sorry, seat A3 is already reserved. It's clear, clean, and completely in your domain language. So when not to make a custom exception is it's really easy to go overboard and create dozens of them, like empty name exception, invalid GPA exception, and so on, when you could have just used illegal argument exception. So before you make a new one, ask yourself, does this represent a new kind of failure that's meaningful to my users or domain? If the answer is no, just reuse an existing exception type, and also never create an empty custom exception class. If it has no message, no context, no behavior, it's just noise. Always include at least a constructor that takes a message and the specific details that cause the problem. So like for example, again, your app tries to uh, reserve seat A3. The system checks and sees A3 is already in the reserved list. It throws new seat already reserved exception, which is A3, and the caller catches it saying, seat A3 is already reserved, pick another, please pick another. So that's it. No weird stack trace or no vague illegal state exception. It's readable, clear, and it communicates the business problem, not the technical one. So some of the things to avoid is don't overuse custom exceptions when a standard one fits. For example, if input is invalid, something like that, you can use illegal argument exception. Always include context. Don't just throw new seat already reserved exception with no message. Use checked exceptions when you want to force the caller to handle something predictable. Use unchecked exceptions for programming errors that shouldn't happen in normal use. Uh, yeah, that's user-defined exceptions have a lot of potential. They make your software behavior clear and your error messages human-friendly. And the last topic is let's wrap up our discussion on exceptions with one of the most common real-world examples you'll actually run into, which is the number format exception. We have definitely seen it before. You call integer dot parseInt or double dot parse double on something that isn't quite a number, and your program crashes with number format exception. For input string something like ABC. So let's talk about why that happens, how to prevent it, and how to recover from it. So what triggers a number format exception? So this happens when Java tries to convert a string into a number, but the string doesn't follow a valid numeric pattern. For example, 3.75 is fine, that's a valid double. 42 is also fine, Java will trim spaces automatically. But something like 3.7 A5 or or a character string will fail instantly. So the rule is simple: if it's not a pure digits plus maybe a decimal point or sign, it will throw number format exception. Now the mistake beginners often make is assuming users will always enter the right format. They won't. So instead of letting the program crash, we need to catch the exception, show a helpful message, and give them another chance. So how to handle it safely is, let's imagine you're asking a student to enter their GPA as a text input, something like enter your GPA. You grab it with the scanner dot next line and then try double dot parse double input. So if the user types 3.8, that's perfect. But if they type in letters 3.8, something like this, 3.8, if they type this, that line will throw number format exception. So that's where you try and catch comes in. You can write something like try to parse the string. If it succeeds, great, move on. If it fails, catch the exception, print something friendly like please enter a number like 3.75, and then prompt again. So that's what we call a recovery loop. The program keeps prompting until it gets valid input or reaches a maximum number of attempts. It's much better than just letting it crash on the first bad input. And next is adding a bit of polish. So before you try to parse, it's smart to use a guard clause. Check whether the string looks like a number. You can do this with quick uh, rejects, I think, like like something like input dot matches um, d plus Yeah, this is very gex, which is, if you are using scanner, you can also, you can call scanner dot has next double before reading it. This way you can avoid the exception altogether for most cases. But even with validation, it's still a good idea to catch number format exception, just in case someone pastes something unexpected. So here's what happens in our, like, an example is the program asks enter your GPA, you type 3.75, it passes off successfully and prints like something like your GPA is 3.75, and you type 3.75 in words, it catches the exception, prints please enter a number like 3.75 and ask again. If you keep failing after say three tries, it can stop and say too many invalid attempts, please restart the program. It's simple, friendly, and controlled. And few things to avoid here is, there are two main mistakes I see a lot with this kind of code. First is letting the program crash. Never trust user input. Always validate or catch errors about around parsing. And second one is catching the exception but doing nothing. If you catch it and just silently skip over it, the user won't know what went wrong. That's confusing and frustrating. So instead, communicate clearly. Tell them what kind of input you expect and how to fix it. Uh, yeah, that's it. No, number format exception is one of those small but constant parts of real world programming. Once you know how to handle it gracefully, you make your programs feel much more professional. Uh, yeah.